Hi there. So today we're going to talk about law of conservation of energy. But before talking about the law, you must know what is energy? What are its different forms? So to get the answer of all these questions, do watch my previous video on the topic energy. You may find the link in the description below. Now here, consider an example where a ball is dropped from a height and the ball reaches the ground. On the top, the ball only possesses potential energy. During the fall, the potential energy gets converted into kinetic energy, and finally, on reaching the ground, the total potential energy gets changed to heat and sound energy. But remember, during the fall, the total energy of the system remains conserved. So students, I hope you understood from this that energy can neither be created nor be destroyed. Energy changes its forms, and whenever energy changes from one form to another, the total amount of energy remains constant. These 3 points you have to remember in context to law of conservation of energy.
Now we are starting with the derivation of law of conservation of energy. In the diagram which is given below, you can see that a body is being dropped from a height A. It reaches to B point covering the distance x and finally reaches to the ground covering the total height h. The body started with the initial velocity u and the body was having the mass m. Now, to show that the law of conservation of energy is valid, we will calculate the energy at 3 different points. So point A, let's say at point A, the potential energy will be the maximum, which is equals to mgh, and kinetic energy will be 0 because the body was at rest. So the total mechanical energy will be equals to mgh. Now we'll calculate the potential energy at point B. Now considering the point B, the potential energy will be equals to mg h minus x, which is the height from the ground, and the kinetic energy will be equals to half mv square. But here we have to calculate the velocity using the third equation of motion, and v square minus u square is equals to 2as we will use, or v square is equals to u square plus 2as. So the initial velocity was 0 and the body has covered 2ax distance, where a can again be changed to gx. So v square will become 2gx. So I will just place it here and I'll get kinetic energy formula as half of m 2gx from this equation, and the final energy will be mgx. Now taking the case of the total energy, so the total energy, which is the mechanical energy, will be equals to mg h minus x plus mgx, which will definitely be giving me mgh, which is same as my first case. Finally, we'll calculate the potential energy and kinetic energy at point C. The potential energy at point C will be 0 because the body has touched the ground, whereas the kinetic energy will be equals to half mv square, where again you will calculate the v square with the formula v square is equals to 2gh. Why gh? Because the body has covered the distance h while falling from A to C. Replacing the value, you will get kinetic energy is equals to mgh Now adding upon the two, the mechanical energy will be equals to 0 plus mgh, and finally it will give me the answer as mgh. That is the same for all the three.
Here you can find the detailed explanation of law of conservation of energy at point A, at point B, and finally at point C. Now coming upon the graphical representation of variation of potential energy and kinetic energy with respect to height. So students, remember, because at the top the potential energy was the maximum. So in the graph you can see that the potential energy is the maximum and the kinetic energy is the minimum. Whereas at the bottom the kinetic energy was the maximum and the potential energy is approximately equals to 0. Thank you for watching. Please like and subscribe. Stay safe, keep learning, stay connected.